All right, everybody, we're going to get started. Hope everyone's doing well out there. I'm Sam Garfull. I work here at OptiPro Systems. Today, we're going to go over what is new with multi-axis in 2021. So let's start off with the big one here. So there's a brand new toolpath in 2021, and it's called 3+2 Automatic. It does exactly as you would expect from the name. It will rough your parts in a 3+2 fashion. They kind of liken this one to the Deber toolpath that came out in 2019, I believe. So pretty much when that toolpath came out, everyone, what they tried to do is select the whole model and say, hey, deburr every single edge on this thing. And generally that didn't work out so well. It works much better if you break it down and you give it some input yourself. Say, here's the edges I want to deburr, or here are the edges I don't want to deburr. This is kind of the same thing, and that's how I look at it as well, is you can tell Mastercam to just figure out how it wants to cut your part. Just say, automatically find the planes that I should be roughing this thing out at. But if you think about it, it's probably better if you give it some knowledge yourself, and that's kind of the results that we're seeing as well. It will work if you just do it automatically, but it might help if you go ahead and say, maybe I want to come in from the top plane, the back plane, and the front plane. So the bullet point here, skill level of programming can be reduced because you don't have to know how planes work to run it, but it would certainly help if you did. It can be very powerful toolpath with the import-export feature. So if you have kind of like a family of parts or parts that look similar that you think it could be beneficial to rough them out from, once again, certain planes, the top, the back, the front, you can import that toolpath, window your part, and you're good to go. So let's take a peek at some of the results that we're seeing here. We're going to take a look at this exact model here in just a second inside of Mastercam, but here's when I let Mastercam figure it out automatically for me. Looks pretty decent, but we have a nice big hunk of material here that we still need to remove. Here is when I went ahead and gave it a little bit more planes. In this case, I just told it I wanted to come from specific planes rather than having Mastercam figuring that out for me. And so one more thing I want to talk about before we jump into that example is bounding box. So if you were around for the rollout on Tuesday, the design one, you've already seen this, but one thing that isn't really pertaining to multi-axis here that I still want to show you is with 2021, it will now always pick up the smallest size box, as you can see by these two pictures down here at the bottom. This one that says 2020, it's skewed at an angle. And when I create a bounding box around it, it picks up those large size. There's a lot of space in between the part and the box itself. In 2021, regardless of how that part is skewed out in space, it will always find the smallest possible box for it. Why I wanted to bring this slide up for multi-axis is for these two features, the solid ones over on the right-hand side. So in 2021, there's a new wrap feature. And what this can be used for in terms of multi-axis is it can be used for your clearance boundaries. So for a lot of multi-axis tool paths, you can select a shape that you want your tool to retract to each time. You can go ahead and window your part, create one of these, either silhouette boundary, which is the top one, or minimum volume, which is the bottom one. Perhaps give it an additional offset, and you can use that as your shape that you want to retract to. The other usage that we've been hearing for this too is you can use it as a rough shape to rough out. So if you're starting with a big chunk of stock, you can go ahead and generate one of these models and you can rough out that shape instead. Just as maybe a better starting point to then go ahead and throw in some tools, knock down some more material. So I want to go over a little bit of that. So I want to just go touch on that before we went into our example here. So let me pull this up for you. And I'm going to talk you guys through how these tool paths work. So the very first thing that you need to do, you need to either go ahead in your stock setup and set up your stock here, or you can do it just by creating a stock model, which is what I did in this case. So this is what our stock looks like. It's just this nice block that we have here. Doesn't matter, once again, if you did that with stock model or stock setup. So after you stock defined, what we're now going to go ahead and do is we're going to pop into the parameters. And I'm going to go back up to the very first page here, which is model geometry. And the one thing that should stand out to you guys in this page is that it looks exactly like a 3D toolpath, right? So you select your normal geometry for machining, your normal geometry for avoidance, and it looks exactly the same as it would in a 3D toolpath. I think this is the only multi-axis toolpath that. But in this case, if you look on my screen here, what we're machining is the green model up top here, and what we're trying to avoid are all these fixtures down below. Let's go to our tool page next, which is our 12mm bullnose end mill. And the page we do have to go to here is stock. So when I go to my stock page here, I need to tell Mastercam what I'm starting with. So in this case, I have it set to stock model, and I have it set to the stock model that I've created up here. You can also, once again, set it to job setup if you set up your stock in the stock setup page. So that's all I'm going to do on this page. Just make sure I tell Mastercam what I'm starting with, and I'll move on to my cut pattern. And this is a pretty standard looking multi-axis page. Go ahead and set my depth step. How much do I want to step down each time? And how much do I want to step over? There is one thing I wanted to mention in here is the type is set currently to dynamic. And so there's a bit of a caveat with that. That's actually not Mastercam's proprietary dynamic technology. It is something very, very similar to that, but Mastercam's isn't quite yet into this toolpath. And there's a good reason for that. But in the coming revisions, we can expect to see Mastercam put their own dynamic in here. But this should work very similar to that still. All right, let's move on to our next page here, which is tool axis control. And this is kind of the heart of this toolpath itself. This is what's going to allow Mastercam to either figure out the planes for you or allow you to go in there and tell it exactly how you want it to cut. In this case, we have it set to automatic, so I'm telling Mastercam to figure it out for me. We have search angle increment, and what this is going to be used for is if you want to snap to specific angles, 0, 15, 30, 45, instead of going to an angle of 22 points something or other. So how much increment do you want to snap your angles to? Max stock to leave, that needs to be larger than the value, or larger or equal to the value that you have in the model geometry page. And max tilt range, that is how much could this thing tilt going from one of these planes to another. Currently we only have that set to 90. Other than that, with this toolpath, there's nothing too earth-shattering. The next page is collision control, and this has clearances for your holder, shank, and shoulder, just like many multi-axis toolpaths would. And then the linking page as well is pretty standard. We have clearance area set to plane, and that's the only thing you have the ability to set it to in this case. It'll always retract in the current plane that you're doing your machining. All right, let's take a peek at this one. I'm just gonna hit the red X so I don't have to wait for it to regenerate again. And I'm gonna play it for you guys in backplot. And I know it might look a little jumpy on the online session. I'm just gonna forward it through a little bit for you guys here. As we can currently see, it's milling from, let's say, the back plane. And after it's done with that, it's going to transition to a different plane. And we'll get there. So now we kind of transition to this 45-degree plane, and we're going to, once again, continue to machine in this plane. And I'll just slide it all the way through here. One thing that I noticed right off the bat is it looks pretty decent, but the fact that I can see straight through to my model there lets me know that we missed a big chunk of material. All right, so that's what you run with automatic. This is what it ends up looking like. It's the same model that you guys saw up on the screen there. You end up with that nice big chunk of material. So let's see how 3+2 automatic works when we go ahead and give it some input. I'm going to click on the next one here down to semi-auto. I'll go into the parameters and show you how this works. And the only difference of this toolpath, everything's set up exactly the same. The only thing that's different is the tool axis control page. We previously had this set to automatic. It's currently now set to semi-auto. So what we're now allowed to do in here is define the planes that we want 3+2 to machine in. So in our case here, if I want to add a plane, I can right click and I can either select add and I could type in the vector, which for me is much easier to go here and say select tool plane. When you go into select tool plane, you have a bunch of options, as you can see on this little select view. You can select either top view, front, side view, isometric. You can grab a named plane, so that would include any planes that you may have created yourself. Or you can do some things on the fly here. We can do a geometry, solid face, and we can simply click a fixture or your model to generate a plane that you want to machine in. So in our case, I'll do something like solid face and turn off all these lines. And perhaps I want to go ahead and click on either a face of my fixture or a face on my model, and obviously it has to be a flat face. I'll click this face on my fixture, and just like you could for normal planes, you can then rotate this thing around for how you want it to tilt in your machine. And I'm going to go with plane 1 here. Z coming straight out of that. And then I've added that as a plane I want to machine in. Go ahead and add another plane if I would like. Do the same thing. I'll select solid face, and I'll rotate to another solid face here, and I'll add that as well. So you can add whatever faces or planes, rather, you would think would be most efficient to machine your part. And I'm not going to hit the green check. I'll hit the red X again so I don't add those in. And we'll see what I did here. And I think, once again, I came in from almost every plane, I think, like 5 sides. I think I came in top, front, back, right, and left. And I think I could have easily omitted right and left and still got really good results. So if I play this thing through, you'll notice it does all those things. It starts from the top, and then it will end up transitioning to a new plane coming from the front. And the one thing you'll notice if you're watching this is it's not spending a whole lot of time in those front and back views. So it's doing rest machining. It's aware of what it's already cut. It's not recutting the entire model over again. Okay, great. So that's what the toolpath looks like. Let's actually take a peek at the stock model, which is, once again, you saw that on the previous slide, that by adding those planes, we get much better results. And once again, I may have went overkill and added too many planes. I could have easily got rid of the right and left and still got much better results than the first fully automatic toolpath. All right, one more thing I wanted to show to you guys here is the wrap feature for bounding box. So if I go into my levels, I already have this wrap created. I did the minimum volume for this one, and you get this kind of funky shape here. And once again, perhaps if we started with a really large piece of stock, this might be a good intermediate step for us. Rough it down to the shape and go from there. So we used this shape for our last toolpath. We went ahead and roughed this shape in, and I'll just show you the stock model. So once again, just a nice little feature. I think they've tweaked bounding box for like the last 4 revisions, so coming out with some really slick stuff for it. All right, let's head back to the PowerPoint here. There is one more thing I wanted to talk about with 3+2, that is. Okay, so I did say that it doesn't use Mastercam's proprietary dynamic technology. And I don't know necessarily the limitations of what's different in those two options. But what can we do if we wanted to use that Mastercam's dynamic technology? In this case, what I did is I did something very similar to 3+2 automatic roughing. Is I came in with a dynamic OptiRough, which is one of my favorite toolpaths to use. And I came in from this and I tacked it from the top view. So I entered right down into this pocket, and as well as the outside of the part as well. And then what I did after that is I took that and I created a stock model from that. So pretty much I had a stock model that showed me everything that first dynamic OptiRough removed. And then what I did is I created another dynamic OptiRough that came in from the front view, and I used that stock model as my stock. So Mastercam knew exactly what had already been machined, so it knows exactly where it needs to cut. So just food for thought. If you wanted to try that out, it works very well. And once again, it uses Mastercam's proprietary dynamic technology. All right. Move on to the next thing here, which is adaptive depth step. So Rotary Advance is one of those tool paths where I've always felt like I wanted more control over. So a lot of times it would be cutting in places and not going down to the floor that I wanted to cut to, even though I specified a decent depth step. So what they've came up with in 2021 is something called adaptive depth step, which makes it so Mastercam will always hit the flat features that you see on your model. So for example, as some comparison, here's how it used to work in previous versions. Let's just say I gave myself here a step down of a 1/2 inch. It took a pass along the outside here, took a step down to a 1/2 inch. And if you can't see my cursor, I'm looking at the left model here, the one below here where it says the word tool paths. And so that one has only 2 passes, as you can see. And the model just to the right of that one has a lot more lines on it. Kind of difficult to see, but it's hitting the actual floor between the fins that we have there. It's hitting all the flat features that you can actually see. So that was once again a big gripe that I had with Rotary Advance. It didn't always hit the material. Essentially, this is going to work like the find flats features, if you ever use that in some of the surfacing tool paths. I also made a bullet point similar to add cuts. It's not exactly like the add cuts feature, but it makes it so you're cutting more material. So making sure you get down to these bottom faces so you don't have to go ahead and run another roughing tool path. Here's another big one, multi-axis pocketing. So in all previous revision, multi-axis pocketing was referred to as multi-axis roughing. That's all you were able to do with multi-axis roughing is to only do roughing. So in this case now, what they've done is they made it a tool path where you can rough and you can also finish. So now this tool path includes undercut roughing, wall finishing, and floor finishing. And that big bullet point down below that is finishing tool paths are designed to use accelerated finishing tools. Okay, so that's a big thing. They came out with these, they gave you the ability to define these finishing tools in Mastercam in previous revision, oval form, barrel form tools, lens form. And they didn't give you great ways to use them. And so now they've got a great tool path that's going to really be able to utilize these tools to their fullest abilities. So in our case here, this page down below in the lower right-hand corner, what we're going to be able to use this page for is tell Mastercam exactly how I want to use those tools. I'll say my preferred contact cutting point is 50% of that tool. Minimum, the least I want to use is 5%, but the maximum I only want to use is 60, because really I don't know if I can get away with using more than that. Okay, so let's take a peek at these tool paths. Load that part up for you. All right. So I already have this one written. Let's go through the parameters and we'll talk about exactly what we did here. And I'm going to go into the right up to the tool first. So let's take a peek at what that looks like. It's an oval form tool. Once again, we're going to try to use as much of this as we can, probably around 50%. Move on here, I'm going to go to my stock page, and I don't actually have to configure anything here for my stock. I would definitely suggest that you configure something for when you're doing roughing, but for finishing operations, we don't have to go ahead and throw anything in this page. Cut pattern. If you're familiar with the multi-axis roughing, this looks very similar still to how that tool path is usually configured. The only difference that we've made so far is switch this drop down from roughing to wall finishing. In this case here, I have my one floor surface, as this floor down here with the 2 holes, and then the wall surfaces are the walls all the way around this part, or that surface, all these kind of bronze looking walls here. Go ahead and set my step over 5 millimeters. And I'll go to my next page, which is tool axis control. And this is the page we saw on the slide here, where we can go ahead and say, I want to try to cut with 50% of this, of the flute length of this tool. Minimum is 5%, maximum in this case is going to be 60. So we'll see how that actually works out when we play it through in backplot. Collision control, nothing too crazy here. In linking, there is something new. There is this new clearance blend spline, which this works very similar to a lot of tool paths. You could say applied on gaps larger than, and you can give it a certain percentage of your tool diameter. And you could say when it exceeds this, I want to create this nice clearance blend spline. I'll also hit my drop down and do a retract clearance area, and that would work just as it normally would for tool paths. Retract to your normal clearance area, drop back down, and start your next pass. So clearance blend spline, we're going to take a peek at that once we play this thing through. Really, other than that, I don't have anything earth-shattering to add here. Let's take a peek at this thing. And it might be difficult for you guys to see. I'm going to try to spin this and get it in a good position for you guys to take a peek at. Get this thing in position first. All right. Let me zoom in and rotate. And you can see the whole point of accelerated finishing tools is we're not just wearing a tiny spot on our ball end mill as we're trying to finish this face. Instead, we're wearing a good chunk of that actual tool. So as you can see there, we got a good fit, about 50% of that tool is contacting at one time. And then we're just going to continue to work our way down these faces. And if you saw that move right there, there's our nice clearance blend spline. I'm going to rotate you again so you can get a better look at that. So if I play that thing through, instead of retracting all the way to our clearance plane, we'll stay inside of this already roughed pocket. And we're simply transitioning just from one finish cut to the next. It's a nice arc move. Okay, this thing's going to keep going. I'll just speed it up a little bit. And as it gets down towards the bottom, it will start taking passes all around that bottom wall, and we'll finish this entire pocket. Personally, I think they're on the right track with this one. I think this is a great idea. The reason I say that is because a lot of times when we're teaching classes here, especially for 3D, we'll do a surface rough pocket or an opti rough. And we'll rough out this whole cavity or this whole part. And then the question we usually get after that is, can we switch that now to finishing? It's like, well, that would be really nice if we could just flip a switch and make that happen. And I think they're on that sort of track, right? So we can go ahead and create a pocketing operation for multi-axis. We can rough out that entire pocket and then copy paste that operation, what have you. And we can go back in and we can switch things to finishing. Now, I want to finish the walls. I want to finish the floors. So I think they're taking a good step in that direction. All right, I got a couple more things for you here. Next one's common direction. This one really helped me out a lot in the optics department here when we're trying to cut some parts. Long story short is sometimes when you're doing multi-axis operations, if you can imagine that little graphic I have down below where I'm cutting this part, if you see that little retract move coming off at that 45-degree angle, perhaps we wanted to use lines to drive our tilt. What you would do in this case is you'd create a line up by where that retract is. You'd draw a 45-degree angle line. And maybe you'd want to do one down below currently where like the flute of the tool currently is, just to make sure this thing always stays at that 45-degree angle. And when I was doing some cutting, we would always notice that we'd have some wobble in our V. It wouldn't be staying right at 45, it would be around 45. And it might be tilting a little bit as it's cutting. And as we know, it would be much more beneficial to simply lock our axes in place. It's more rigid that way, and we can just walk our way around our part. That's what common direction will do for you. If you set yourself that line to a 45, you say common direction, it's going to keep you locked in at that 45-degree angle as you're going around your part and machining. So what they've done now, this has been in the system for years. They've added it now to MORPH, parallel, and along curved toolpaths. This is a pretty small one, but it's honestly my favorite that they came out with for multi-axis, extend to edge. I run into stuff like this all the time. So if you could see the model I have up there with the two blue lines. So my example of how I usually run into this case is, let's say the actual model was truncated to where those blue lines are. So if you draw a line between those two blue lines, the ends of them, let's just pretend like we cut the knife or cut the model with a knife right there. So let's say that was the original size of the model, because what I usually do in this case is I'd come in and I would do a push-pull. Like I'd write a blend or a morph, and maybe it's not leading off of beyond those blue lines like I'd want it to, so it's not actually coming off my surface. So what I would do is I'd go in my model prep tab, I would use the push-pull function, and I would physically grab one of those faces and I would pull it out a certain distance, so let's just say 1/2 inch. And when you do that, you end up with this exact picture that you have here, where your lines are a certain length, but you've pulled the model further out beyond those lines. So what you run into that is you end up with some goofy results for morph. So a blend toolpath in this case would just stop where your lines end, so you'd have to physically extend them yourself. With a morph, it gets really funky. So once it gets beyond those lines, it starts to kind of wrap itself around the surface, and you end up getting some really big scallops in that case. So what we can actually end up doing in this case is just check a box, extend edge curves, and it will extend these edge curves theoretically to the edge, and it will cut like that. So let me show you what I mean. And I tried to get that nice model that they had there up on that slide, and I couldn't do it. So you guys are stuck with my modeling skills. Okay, so here's what we have. Almost exactly like the model we have on the screen, except not really at all. But we're going to go ahead and try this morph toolpath here. And if you've never used morph before, grab a tool. How it works is you're going to select 2 pieces of wireframe that you want your toolpath to morph between. These could be any shape, but in our case, it happens to be really easy. They're just 2 straight lines. So I'm going to make this my from curve. That's where my tool is going to start. And my pattern to curve, which is where the toolpath is going to end. I'm then going to go ahead and select my drive surfaces of what surfaces I actually want to cut. All I have to do here is give it a step over. Currently I have it set to zigzag, and that's fine for what we're doing. Let's go to the tool axis control page. And I did want to make a mention in here. If you guys don't use morph a lot, first of all, it should be one that you use for multi-axis. It's a great toolpath. But my suggestion is also to use it for 3-axis stuff as well. Morph is one of my favorite surfacing toolpaths. I'm a big fan of blend, and morph is essentially blend on steroids. Okay, this thing has a lot better results when it comes to tool contact. I would say if you're ever having trouble getting your blend to work, give morph a try. It's a really powerful toolpath, not only for 5-axis, but for 3-axis as well. All right, and there's nothing crazy in here. I'm just going to go ahead and hit the green check and generate this toolpath. Let's see what it looks like without having that box checked. So this is what you end up with. Let me zoom in on an end here so you can see it a little bit better. So you can see as you start to get out towards the edge beyond those lines, your toolpath begins to kind of fan out, and you can see the big spacing between these passes. We're going to have some big scallops in these areas. So let me zoom back out here. We'll pop back into the parameters of that toolpath. And let's go ahead and make that change. Where this checkbox is actually found, you're going to have to hit the plus next to cut parameters. That'll expand out some options for you. And now we can go to parameters for surface edge handling. Extend edge curve. Let's give that a check. We'll regenerate our toolpath. And I'll zoom in on that same section for you again. And once again, what it does is it ends like your wireframe actually went all the way to the edge. So now we get these beautiful straight lines all the way through, and that's what we were looking for initially as well. So, all right. Last one I got for you here, just another small change they came out with in 2021 is you now have the ability to manage your feed rates for certain lead in, lead out moves. So this is available for curve, flow, multi-axis, or multi-surface, swarf, and port toolpaths. And essentially what it allows you to do is allows you to specify a percentage of your feed rate. So you could say, I want my entry move to be 50% of my feed rate, same thing with my exit, or you guys can make them different as well. All right. If that's it for me here, I did want to mention Sandy has been sending out emails with all of the videos of these PowerPoints. So if someone in your company was not able to attend, you could send that over to them as well. And she also has some of the part files that we've gone over, so you guys can go ahead and open those up, play around with them as much as you'd like. Other than that, feel free to give us any contact for any Mastercam support. I do a lot of post stuff as well, so feel free to get in touch with me for that as well.